In this problem, we have a container containing some fluid inside it, okay? The density of the fluid is rho and the height till which the fluid or liquid is present inside the container is, let's say, equal to h, okay? So the container contains the liquid which has a density of rho. Now what is done is a very small hole is made on one side of the container. The hole is present at a height of y from the bottom, and what would happen? The fluid would start coming out of the container. In fact, the fluid would fall somewhat like this. It would fall onto the ground like this. What you have to do is, you have to find out the distance, okay? The distance at which the fluid will fall onto the ground. Let's say this distance is x. You have to find this x. How can you do that? So this is the first part of the problem. You have to find out x. The second part of the problem is, you can understand that if I make the hole over here, if I make the hole over here, if I make the hole over here, if I make the hole over here like this at various points, the fluid would fall. But the distance at which the fluid would fall on the ground would keep on varying. So maybe if the hole is made over here, the fluid will fall like this. If the hole is over here, the fluid will fall like this. Here, the fluid will fall like this. Here, the fluid may fall like this. Here, the fluid may fall like this, okay? So the distance would keep on varying depending on where you make the hole. So what you have to do is, you have to plot x against y, okay? So in that case, x becomes a variable, y becomes a variable, because you are changing the point at which the hole is made. So depending on the position where the hole is made, the distance at which the fluid will fall would be, okay? So you have to plot x against y. So basically on the x-axis, you will be plotting y. On the y-axis, you will be plotting x. Let's not get confused with the terminology. What I mean to say is, on the x-axis, you plot the position at which you make the hole, and on the y-axis, you plot the distance at which the fluid will fall. And as third part of the problem, you have to find out the position at which, if you make the hole, the distance would be maximum. So you have to find out x max, and for y at which the distance would be maximum, okay? So these are the three things that you have to do. One more information that is given to you is that the cross-sectional area of these holes, okay, let's call that as A1, is much less as compared to the cross-sectional area of the container. Let's call this as A2. Okay, so A1 is much less than A2. Try this problem out. If you are not able to do it, the solutions are coming up in the follow-up videos. Thank you.